Hi, I'm Kate.
And I'm Hank.
And we're from the Comp 110 team here at UNC.
And we're going to help you learn to program. Woo!
Yay! Hey everyone, this is Kate and Hank again.
Hey, how's it going?
We're just going to give you another review video for our midterm number 2. And this video is going to go over loops. So we're going to go through what is a while loop, what is a for loop, what is a for each loop, when do you use them, what's the difference, and what are arrays and array lists, and strings. So we're going to touch a lot of things that will hopefully help you guys with the midterm. Perfect. So let's start from the scratch. We are going to go ahead and make a new class. For this, we're going to be using loops. And what we want to use loops is some numbers in this scenario. So we're going to make a new bank. Our object is going to be a bank. So we'll go ahead and name our class bank and finish this. Perfect. So here's our bank, and in our bank we are going to create an instance variable that's an array.
Yeah, so what are some of the things that all banks have? We talked in our last review video about how each class or object in Java or an object array in programming has attributes or properties to it that are instance variables, and then things it can do or actions that are the methods. So for our instance variables in a bank, we're going to have an array of deposits that we've made into this bank. So whenever we want to hold multiple values of something, we use an array, and this is going to be an array of type, an array that holds ints. So this syntax is a little weird, but with the square brackets, all this is saying is set up an array that holds ints. So an int array, and we're going to name this deposits. And we always make our instance variables private in Comp 110. So then this instance variable has not been initialized now, and we're going to do that in the constructor.
So in our bank, we're going to have our bank constructor take in a array of ints called deposits. So it's going to take in our amounts that we're depositing. And we're going to go ahead and then initialize our deposits. Okay, so we're going to have, whenever we make this bank now, we're feeding in an array of deposits, right? Because you want to tell your bank what you're going to deposit, and then we're going to set that to our instance variable. That way we can use it for each of our methods. So our methods that we're going to write are going to be different ways of summing up those deposits using while loops, and for each loops. This is an array. So we don't know how long it is. All we know is that we want to go through each index of it and add whatever's in that index to our sum variable, which starts at 0. So we're going to start with the first index, take what's inside of it, and add it to sum. And then we're going to increment I up by 1. So now I went from 0 to 1. Then we go to the next index. We take what's inside of it, add it to sum, and we increment I up by 1 and go to the next one. And we're going to keep going until we get to wherever that end of the array is, wherever the length is. And I is 1 less than whatever that value is. So say our length is 5, like it is in our array we initialized in our main. Then we're going to only go to the index I equals 4. And we're going to go one by one, adding them to what we already have as sum. So once you've deposited, your bank has to go there and sum them all up and put that in your account, right? So let's make some methods that will take your array of deposits and sum them up so that they know how much to put in your account. And we're going to use different types of looping to do the same thing so you can see how they're different.
So the first method that we want to write is going to return an int because it's going to return a sum, and we're going to name it sum while because we're going to use a while loop to sum up our deposits. Now the first thing that we want to do inside this loop is set up a variable to keep track of our sum because we know we're going to have to return a sum at the end, so we'll initialize our sum variable to 0, and then since we know we're going to do a while loop, we need an I to keep track of the index that we're at within the while loop. So we'll initialize that to 0. And then within our while loop, what's the condition that we want to loop until this evaluates to false? Well, we want to say while I is less than the number of things in deposits, right? And since deposits is an array, we can get that number by calling deposits.length without parentheses, because length is a property of deposits, not a method that you call on it. So now we have while I is less than deposits.length. And if we do anything inside the while loop without incrementing I at the end, we'll hit an infinite loop. So I always like to write in I plus plus or whatever plus plus at the end, like first thing while you're writing the while loop, just so you don't forget. Then we can go back and now this block of code will run the number of times as many things there are in deposits, as long as we remember to increment I at the end. That's very easy to forget, but very important. So on each loop, the main thing that we want to do is add our whatever value is in the current slot of deposits to sum. So we'll say sum plus equals, and remember that's the same thing as saying sum equals sum plus something else. So sum plus equals, and then how do we get the value at the current index of deposits? Well, since deposits is a native array, you can use the bracket syntax like this, and just say deposits, whatever is at the index I in deposits. Great. Now our while loop is done, and at the end of our method we can return sum, and there we go. That will sum up all of our deposits using a while loop. Great, so now we want to do the same thing using a for loop. So pause the video and see what you can come up with to re-implement the same method, only using a for loop instead of a while loop. Alright, so our method will still return an int, and we're going to name it sum4 this time, since we're using a for loop. And we still want to set up a sum variable to keep track of our sum, but we don't need to set up our I variable right there, because we do that as the first thing inside our for loop. So we're going to say for int I equals 0, and then comes the condition, so I is less than deposits.length, and then I plus plus. So notice this has the same basic components as our while loop up here, and Java will treat this identically to this while loop construction up here. This is just such a common block of code to write in programming that there's a special way of writing it. So while loops are good for if you want to run a block of code until something happens, or and then for loops are good for when you want to run a block of code a certain number of times. So we know we want to run this block of code the number of times as many things as there are in deposits. So a for loop is a good choice for us here. And then inside the for loop we'll do the same things we did above. Add to our sum the current value, or the value at the index I in deposits. And then we don't need to increment our I again because we did that inside the parentheses, and then we will return our sum. Great, so that's how you implement the same method using a for loop.
Great, so can we check if this works, Hank? Like, how do we print this all and see if we're depositing what we want?
Yeah, so let's make a new class, and this class that we're making now would be equivalent to like the runner in all of your problem sets. So we'll name it runner.
That sounds good to me.
And inside the runner, we're going to have a main method. This is where our program's actually going to start. And the first thing we're going to do is set up a new instance of our bank class. So we're going to say, no, let's start with bank. We're just going to name it bank and set it equal to a new instance of our bank class.
Great. And we have to feed in an array, right?
Right. So we can make a new array of ints and specify in curly braces here what values we want in that array. Then we can call our methods now that we've created from our bank, but nothing will happen if we just call the methods. We have to print out the results. So we're gonna system.out.println bank dot sum while, and that should give us the same thing as saying bank dot sum for. Let's see what happens.
Yay!
Great, so we have $437 in our bank account.
Okay, great. So we have a sum while and a sum for. What about those for each loops?
So with for each loops, the syntax can look a little weird at first, but it's really simple once you get the hang of it. This is a for each loop, and it starts out with the word for, just like a normal for loop, and then it has two things inside the parentheses separated by a colon. The thing on the left side is like a placeholder variable for each singular thing that we're looping through. So the way that you define that is any type t, and then a name for the variable of each of the things that you're looping through. Then after the colon, we specify the group of things that we're looping through. And that group has to be something iterable, like a list or an array. And that has to contain elements of the same type t that we declared at the beginning of the for loop.
Back in our bank class, let's go public int sum for each. And for each, what it does is it's exact same thing as an iterator. So we're not going to have time to go through an iterator very closely.
And it won't be on the midterm, so don't worry.
Yes. All right, so we're going to do a for each loop now to sum all of our deposits. So remember, for a for each loop, you have to be iterating through something that's iterable. So in this case, we have an array, and we want to get each thing and get each value of money in each index of it. So it's iterable. So for each, and we have to say each int dollars of our deposits, we are going to, and once again, we need that placeholder int sum equals 0. We're going to do the same thing we've done for all of them. Sum plus equals equals dollars. So you even saw there, I hesitated and started to say deposits.getI, but what this is doing is it's literally going from one deposit to the next. So you know that the current dollars is the current deposits.getI or deposits.I in this scenario. And then we're going to return sum.
Awesome. That's a lot simpler than all of this crazy for loop that we had going on earlier.
Yeah, it looks cleaner. Okay, so let's test it and see if it works. Let's add it to our runner. So, all right, let's see if it's the same as the other two. It's the same. So cool. Okay, so let's say the bank breaks down and something in its system is making it so that it only sums up every other deposit. So how would we change a while loop so that it's only summing every other deposit? So if we think about it, we're looking at an array, and our array and our runner happens to have 1, 2, 3, 4, 5. So if our bank breaks down, it's only going to add 300 plus 6 plus 2 in this scenario. So it's going to be missing $45 and $84. So basically, when we call the sum while in this scenario, it's going to take the first index, it's going to jump over the second, it's going to take the 0 index, jump over the second, it's going to take the 0 index, jump over the first, take the second index, jump over the third, and take the fourth index. So we can change how we're incrementing I in this case. I plus 2. Let's see how that changes in our runner. So yeah, 308 is exactly 437 minus 45 plus 84. Okay, so it also breaks down. Let's change sum for. So what do we change here if I is incrementing differently? Where are we incrementing?
At the end of the for loop inside the parentheses.
Perfect. So I equals I plus 2. Perfect. Let's see how it changes there. Okay, also 308. Okay. Now, take a second to think about how do we change the for each loop so that it only takes every other item and adds it to sum.
Well, every time we go through the for each loop, we get it just always increments by 1, right? And the dollars just becomes the next element in the array.
Right, because it's an iterator, basically. A for each loop is an iterator. So it's asking, does it have next? If it has next, I'm going to take it. So unless you were to write your own type of iterator, it's always going to just take the next index. And we can't change that with a for loop. So actually, with a for each loop, the bank's never going to break down because it's always going to take the next deposit value. Great, so this is why we choose what type of loop to use. You'll use a while loop and a for loop interchangeably, but you can only use a for each loop when you want to get the next value each time.
Right.
Perfect.
So we've been using, these are called native arrays so far with these square brackets. But there are also classes that implement arrays in more advanced ways than native arrays. So like if we wanted, so native arrays are a fixed length. Once they're established, you can't change the length of them. Because what's really going on inside your computer is your computer allocates a certain amount of memory for that array. And you can't dynamically change how much memory that variable takes up once you've declared it. But with things like array lists, they set up a really large amount of memory at the beginning and then allow you to add things or take things away from the array list as you go. So if we wanted to be able to change the size of the number of things in our deposits as we go, we should make it, instead of a native int array, an array list. So we're going to say this is of the type list, and it's a list of here, and so I instinctively typed ints here because that's what we've been talking about. But we're actually going to have to use the capital I class integer here, and that's for reasons that you don't have to understand super clearly for the midterm. And because this is like a more advanced class, we're going to have to import it from java.util. Perfect. And then inside the constructor, this now, instead of taking an int array, is going to take an array list, which we will have to import as well. So why did I write two different things here? We have list of integers and array list, and this will also be an array list of integers. Remember when we talked about interfaces and classes and how interfaces were like the definition of what something could be, and then classes were a certain implementation of it? This works in the same way. List is one of those abstract data types that we talked about in lecture earlier. You can think about list as like an interface, and then array list is a certain implementation of a list that comes with Java. So a list is kind of what you'd think of it as, just a series of items. And you can imagine that there would be some different ways you could implement the specifics of how you represent a list in a program. So list just means overall it is a list, and it has certain like methods you can call in it. Array list is one kind of common implementation of the list that comes with Java.
Okay, so now we see all these red X's here and there, and that's because we're doing certain things that work for arrays that are native and not for array lists. So take a second and look at these two lines here and change them so that they have the syntax of an array list. Great. So instead of length, we're going to do dot size, because that is the method call we call on an array list. And then instead of deposits I, if we're going to get a value at I, we literally say get I. Perfect. And now it works like that. Okay, and now how do we change this one? It's exactly the same. We're going to say deposits.size, and then deposits.get I. And the cool thing about the for each loop is we didn't have to do anything, because whether deposits is a native array or an array list, it's iterable. So it's the same thing and the same instance variable. Very convenient.
That's awesome.
So let's look at our runner and see if anything there needs to be changed. Wow, this is red. Why is this red? Take a second to think about how we need to change this declaration and instantiation of bank so that it works. So now we need to change our instantiation and initialization of bank to contain an array list. Because if you look back at our bank, our constructor in this scenario has an array list of integers instead of a native list of integers. So let's go ahead and make a new instance of array list. So list integer array equals new array list integer. Remember these parentheses because it's a class that we're referencing. And we're going to have to add the array list once again to this class. And now we need to add the values we want to add to it. So we'll say array dot add. Remember this is a method that we have for array list. And let's go through and add the same values. Great, so now we have this array that's filled just like our native array. And let's go ahead and add it to the bank. So how do we add it to the bank? All we have to do is feed in that variable. Okay, so let's give this a run and see what happens. So let's see if the sum while, the one that, well, all of them are the same that we had. I don't remember exactly what it was, but something like 438. 437, exactly. And then these are 308 because once again, remember we changed it so the bank was deficient. So Hank and I, we've been really thinking things through now that we have a lot more money.
And I think we're really ready to take the next step in our relationship, Kate.
Yeah, I think we can afford a third member of this family.
I agree. I'm so excited.
Me too.
But do you know what the biggest problem is?
Yes.
What are we going to name the baby?
Exactly. It causes me so much anxiety.
You know, I think as computer scientists, we can solve this problem with a new Java class.
Exactly. Let's make a class to figure out what we're going to name our new child.
Awesome. So we'll make a new class named Baby Namer.
Names. Baby Namer. I like that.
Baby Namer. And this class, I want our baby's name should reflect something of both of us, right?
Something of both of our names.
That's a great idea.
Yes.
So I think the instance variables of this Baby Namer class should be both of our names,
Oh,
right?
that's a beautiful idea.
And then it will take both of our names and do something to it and spit out a beautiful name for our lovely child.
Oh, I'm so excited.
So we're going to have instance variables that are private string, and we're just going to say Hank, and private string Kate.
Great.
And then our, you're right. And we always put underscores at the beginning of our instance variables in component. So then in our constructor, Baby Namer doesn't take any parameters, and we're going to initialize Hank and Kate to the proper string values.
Great.
Awesome.
Okay, so just so you remember, strings are arrays of chars or chars. So if you write out Hank, Kate, our initial baby name idea, and we go through each one, H is the 0 index of this string, and then A is the second one. And remember, when you write a char, the little letter, you surround it with one apostrophe and another apostrophe instead of two quotations. That would be a string. A char is just one.
So what kind of method are we going to write to generate our baby name?
Well, why don't we have a method that takes the two strings of our names, puts them together, and then gives us a baby name that's every other letter of our name that's together.
That's a great idea. What are we going to name this method?
Baby name.
Baby name.
Great.
And
So, all right, we're going to start off by just saying we don't know what we want to do with our names together with our baby, but we know it wants to contain both of our names.
yes, I completely agree.
Okay, so let's go ahead and make a value that is a string that's the concatenation of our names. So
Great.
string concat names equals Kate plus Kate definitely comes first.
No, I think Hank coming first definitely
No,
sounds better.
nothing that starts with sounds good. So Kate
Fine.
plus Hank. Great. Awesome. So now we have this string concat names, and just right here, take a second to think, what is inside this string? What does it look like? Okay, great. So our starting name for our baby is Kate Hank. Kate Hank. Kate Hank.
I like it.
Kate Hank.
It's
Okay.
almost a beautiful baby name.
It's almost, but we're going to make this gorgeous. So I'm thinking to start off, why don't we take Kate Hank and take every other letter of it and see if it comes out with something beautiful.
I think it will be.
Right, so instead of summing integers in this case, we're summing what? Cars.
Characters.
Right, we're summing characters. Car or char, your choice. But this is important to remember. String is capitalize S, because string is an object. It is a class. It is an object of an array of characters. So if you think about it, this string, Kata Hank, is one car plus another car plus another car plus another car, all the way to the end. So just like we can take the length of an array, we can take the length of a string. So let's do a for loop.
That sounds good.
It's pretty efficient. For,
I think our baby deserves a for loop.
yeah. Why don't you all, we're going to pause here. I want you all to finish this for loop for a second. So once you finish this for loop, what should I always be less than? It should be less than concat names dot length. Great. And then I plus plus. Cool. And then what do we want this to do?
So before the for loop, we'll want to set up a variable to store the name of our beautiful child. So that is going to be of type string, and it's going to be beautiful name.
Oh, yeah, that's a good one.
Yeah. And we're going to initialize it to just an empty string, because before we loop through, it doesn't have anything in it yet. And then we want to modify this like standard for loop header here, because we want to take every other car in Kate Hank. So we're going to say I plus equals 2. Great. So then inside the for loop, we're going to add to our beautiful name. And just like in summing ints, we can concatenate strings together with plus equals, with the plus sign, just like with ints. So beautiful name plus equals concat names dot, and then we can use this char at method to get the character at a certain index, and we're going to say I. So on each time we loop through, we add to our beautiful name variable the character at whatever index I is currently at. And then at the end of the method, we'll want to return our beautiful name. I'm so excited to see what this ends up being.
Yay! Oh,
I spelled beautiful wrong in all of these.
well, we'll keep it there.
So I spelled beautiful wrong in all of these, and it's a really cumbersome task to go through and change all of them, but you can do some magic here and change all of them at the same time, and we're going to show you cool Eclipse tricks like this in our upcoming video all about tips with Eclipse.
Okay, so let's go ahead and let's just put this in the same runner as our bank account, because we now have money to have our child, so we might as well, and thanks to the bank account, run it all in the same place.
Yeah.
Okay, so we're going to need to add a new instance of baby namer to our runner. So take a second. How do we add a new baby namer, and what is it going to look like on this line? Okay, so now that on your own you've instantiated and initialized a baby namer, on this line here, go ahead and try and print out the result of calling our method baby name on that instance. Okay, so it should look like this. All right, let's see what happens. Cuthin. Cuthin. It's like Keithan. Cuthin.
Keithan.
No.
That doesn't sound very good. I think it'd sound better if you put Hank first.
I'll mark that. Yeah,
No, it's
oh, this is hunked. I like hunked. Hunked is a very hearty name.
Maybe if we were in Game of Thrones, that would be an appropriate name for a child.
Okay, I think our problem is that all the vowels are second.
Yeah. What if we start I not at the first character, but at like the second?
So at 1.
So at the A in Hank.
Okay, let's see what happens. Ake.
I like that.
Akaye.
Akaye.
Akaye. Okay, I think Akaye is pretty good, but we want to know what you think.
Right. So in the poll on the side of the YouTube video that we're going to add hopefully later, let us know which baby name you think was best. And if you can come up with any other baby names from Hank and Kate, please comment below. And the winner of the baby name contest will get a shout out in the next video.
Exactly. So keep trying. So far we've got Hunked and Akaye. I'm personally a fan of Hunked because it's pretty hardy, but we'll see what you guys think. So
yeah. Good. So good luck everyone on the midterm. Remember to get a good night's sleep. And yeah.
We hope you all enjoyed learning about the difference between while loops, for each loops, and how strings are just an array of characters. So
see you in the next video.
see ya. Bye.